This is the screencast for section 5.2, example 6. We're going to prove some identities that are useful in calculus. Really, in my opinion, all of these are useful for calculus. The trig identities that you've been learning in these last several sections do come up every so often in calculus, and there's really no predicting when or where they may arrive. You kind of are just expected to know them or be able to look them up. So we're going to start out by proving the following identity, that sine squared times cosine to the fifth of x is equal to that big old mess. Well, man, this is tough. On the right side there, I see that is definitely more complicated. On the left side is more simple. Which one do you want to start out with? Well, on the right side, I could start by factoring out a sine squared. Or on the left side, I could start by breaking up cosine to the fifth into 1 minus sine, or 2 cosine squareds, which would break up into 1 minus sine squareds. It's your call. I'm going to start out by the left, by working with the left side. Sine squared of x is going to stay sine squared of x because I have mostly sines in my goal expression. The cosine to the fifth, though, I'm going to split that into cosine squared of x times cosine squared of x, and then times cosine of x. That cosine of x I see in my end expression, so I'm going to kind of hang on to that, and I'm pretty sure that won't change. Now, cosine squareds are they're equal to 1 minus sine squared. So I'm going to change each of those to 1 minus sine squared of x. Now I get to distribute and multiply all that out. I'm going to leave this sine squared by itself. But now I have 1 minus 2 sine squared x's, and then plus sine to the fourth of x. Now remember I said the very first step, if you were working with the right side, would be to factor out sine squared. Here's your sine squared factored out, and now we're going to distribute it in. Sine squared x minus 2 sine to the fourth of x plus sine to the sixth of x times cosine of x equals exactly what I wanted it to. Sine squared of x minus 2 sine to the fourth plus sine to the sixth of x times cosine of x. Now in the now try problem, we have the same circumstances as example 6, a high power of a trig function on the left and something that looks like it can be factored on the right. So I'm going to work on the right side with this one to show you a similar situation of how I could have started the example 6. Now on the right side, I want to factor this, but there's too many cosine squareds in here, so I'm going to change my u to be cosine squared of x. I'm going to use my u substitution. So now I can rewrite the right hand side as 1 minus 2. Now instead of cosine squared, I'm going to call that u, plus, now instead of cosine to the fourth, that's cosine squared squared, so u squared, times sine of x. I'm going to rewrite u squared, let's see, minus 2u plus 1 times the sine of x, and I can factor that into be u minus 1 times u minus 1, which is technically u minus 1 squared, sine of x. Now since u is cosine squared, I'm going to put that back in. Cosine squared of x minus 1, sine of x. Cosine squared times minus 1 is sine squared of x from my Pythagorean identities. So now I have sine to the fifth of x is equal to sine squared times sine, which is sine to the fifth of x. Another example I want to show you is when I have a high power of two different trig functions. I have a sine cubed and a cosine cubed. Well, my goal has all sines in it. So I'm going to leave sine cubed alone for right now. And I'm going to work by breaking up cosine cubed. sine cubed x, I'm going to change cosine cubed to cosine squared of x times cosine of x. Now I have that singleton cosine of x, which looks like I need it in the end result, so I'm going to keep that in mind, that that's going to stay, and I don't want to change it in any way. Cosine squared is 1 minus sine squared of x. Now I can distribute in sine cubed of x minus sine to the 5th of x times cosine of x equals just that. Now if you want to see how I would have tackled that from the other side, if I were working from the right side, I would have factored out a sine cubed from both terms. Just like my last step in working with the left side was distributing it in, now I'm going to factor it out. Sine cubed of x, which would be 1 minus sine squared of x, cosine of x. 1 minus sine squared is cosine squared of x. And then my last step would be sine cubed of x cosine cubed of x equals the same thing, sine cubed of x cosine cubed of x. You don't have to work these from both sides at all. I just wanted to show you the left side versus the right side. In my opinion, they are very similar, equal difficulty. It's just a matter of which you want to start with first.